weeks into something called the definite integral. Okay? No, this is much easier. Ready? We have short time, so let's focus. The definite integral you have actually seen already. We used this notation, correct? With approximations of area under a curve. So what the definite integral actually calculates is the exact area under the curve. So this means calculate the area under more buzzwords in there. The graph of f of x equals x squared from x equals 0 to x equals 4. That's what that means. S4 is
looks like that's okay.
It's called an integrand. Integrand. These are called integrand. Limits. Our favorite calculus word. Okay. So there's your vocab lesson. I'm still going to expect you to use your approximations and combinations, right? You can see from the three responses and stuff. But most of what we do for the new material is calculating exact areas. Okay, so again, if you want to picture this, we are calculating the area of that shape. Exact. So, you okay with that? Big idea? Got it? This is beautiful. What? Beautiful. You know how to, let's see, okay, so you know how to calculate the antiderivative, right? Ah, I heard a plus C. This is where we get rid of those. No, it is dope. No, it's not dope because it's not great. Okay, thank you.
Learn all this stuff and you're told me. I was careful. I like
Yeah, that's just the bar. Okay. So you have calculated the antiderivative. The integral is gone now. We are. This says evaluate from 0 to 4. So if you're going from one step to another verbally, x cubed over 3, evaluated from 0 to 4. That's our verbal cue is. Okay? That's what this bar means. And you should have seen that in derivatives as well. Right? In derivatives, we would write dy dx evaluated at x equals 2. Yeah. Same idea. Okay. Here's how you evaluate it. Okay, I'm going to plug 4 in and cube it. Get ready. This is going to blow your mind. I mean, like, whoa. Like,
plug the 4 in, subtract, plug the 3 in, with the 0 in. You got your area. If you start at 1, a 1 goes here. Okay. Whatever numbers that you're working with, top minus bottom. Top minus bottom is going to be a theme for this quarter. Okay. 64 over 3. Kate, you asked how we do those so fast in our minds. Right there. It was 0 to 2 ended in my head.
0 to 2.
Yeah. See, 0 to 2 is just 8 over 3. So that is a basic calculation of a definite integral. Okay. So any antiderivative you know you can now plug in. So let's say, can I move? What's the rudder? Calculate. Integral from power 4 to power 2 of sine theta. Dead serious. I just threw down the gauntlet. No.
Why can't we do that?
We're studying trigonometry and pre-calc, and I'm just in trigonometry mode. So theta, fine. All right. What's the antiderivative of sine? Right? Think derivatives, right? What's the derivative of cosine? Negative sine. So I have to compensate. Well, I'm compensating in here. All right, so cosine, negative cosine evaluated from power 2 to power 4 is no, you're not. Again, in here, you always simplify. Okay? This is not an answer because this is not the numeric number. It's a function of a number. What's cosine of power 2? Somebody said it. 0, thank you. Woo. And cosine of power 4? I learned something really neat from a student today.
From a student?
Take your left hand. Right? This is power 4, correct? So you have 0, 30, 0, power 6, power 4, power 3, and power 2. 0, 30, 45, 60, 90. Right? This is power 4. Cosine is root 2 over 2. 2. Sine is 2 over 2. Okay, consider pi over 3. You put this finger down. Cosine is 1 over 2. Sine is root 3 over 2. Yeah, they're all over 2. Okay. So, again, we're in power 4 mode. Root 2 over 2. Root 2 over 2. And pi over 6 would be root 3 over 2 for the cosine, 1 over 2 for the sine.
Genius.
That's a neat trick.
Was that like a BC student?
There's your, no, this is a pre-calc student that showed me that. Today. I learned that today. Carhartt's one too, right there. Yeah. So here is your area. So if I'm going to draw this,
Everywhere.
here's sine theta, right? From pi over 4 to pi over 2, we've just calculated the value of that area. Good. What if I were to calculate that area?
Which area?
This right here.
The whole thing?
Yeah.
So
So
be that other areas.
how about we do that? Let's go pi over 2 to 3 pi over 4 of sine theta. And this is your turn. Ready, set, go.
Is this square root of 2? What's that? It just makes sense.
This is your time to practice. Make sure you got it. So take advantage of that. How can I help you?
Give me first grade math.
That's fine. That's all right now, that's all you need. Is your notebook in front of you to do this. Daniel, what's the antiderivative of sine theta? Right, okay, so negative cosine evaluated from
So you need
3 pi over 4 is that's this is pi over 2 to pi. Sorry. I just realized that. It's okay, it doesn't change. It doesn't change anything. Pi over 4. Pi over 2. We calculated this area. Now you're calculating this area. That's this. You gotta keep an eye on this. Remember I told you that? No calculator.
Why?
What? Let's see, 3 pi over 4.
It'll be negative.
Cosine at 3 pi over 4 is negative root 2 over 2. The negative of that makes it positive. And then pi over 2, 0. There you go. It's the same answer? Yeah. What? Shouldn't be. All right. Let me hear that.
I have a question.
Canyon, I'll be ready.
So, you're going, first you're going to have a
Hey, we're losing focus. If you don't get it, the best time is to really lock in. Canyon.
You're going to have us calculate the area.
Yeah. Okay.
That's going to change the value of the area. Like, does that change the value of the area?
Boom. If I were to calculate no, quit it. If I were to calculate this area, right here, it is a negative number because it's below the x-axis. That's why these are positive, because they are above the x-axis. If you dip below the x-axis, it's going to give you a negative area, because the negative area makes sense geometrically. No,
That's just kind of the rule, just to let you know.
but again, remember in calculus, negatives determine direction of travel, location. This is one of those location things. It just means where it's located. It's not a negative area per se. This will all be provided. You have to calculate all this. Is that your question?
And then, the formula in general is integrand with x to the top of the bottom.
Right.
And then x.
Yeah, in general, we would write it like this. We'll formalize this as the fundamental theorem of calculus here next week. Okay. So, but I'm not going to expose you to the generalization of it quite yet, but that's where we're headed. Yeah. Right now, I just want you to be able to calculate these answers, okay? Do you have any questions? Elizabeth, you doing okay? Let me write it down. So,
Like it back.
P. Okay, so that's everything from 5.2. This is not due until Tuesday. This is due tomorrow. Okay, so all I'm asking you to do tonight is this little bit. It's all odds. You can check all your answers. But telling you, if you don't show your work, I'm going to give you a 0. Yeah.
So show your work.
33 through 39 odd. Again, don't worry about this yet unless you want to.
So-
I'm asking you to complete this work tonight.
So you want me to write out, like, what if, okay, what if I just do like negative, what if I just show negative cosine pi or minus whatever, right?
You can eliminate this step if you want. What do you want? Snap your fingers at me? Can I have you? Okay, you got about 5 minutes.